हेलो मेरा प्यारा प्यारा बहुत अमेजिंग वाला बच्चा लोग here in the classroom. So hi, hello everyone. जल्दी everyone update me in the chat box how you all are doing and how many of you came well prepared for this marathon series. है ना? Everyone here in the classroom, let me see. Hi Prapat, Preeti, Ujjwal. Then who all we have? Sabra, Kanak, Chowdhury. Okay, shh. Okay, some shh person is there. Jyoti, Asta, Preeti, Kanak, Ankit, Abhilasha, Shreya. A big hi, a big good evening to everyone here in this Bachalu. Okay, a big good evening to everyone. So someone is asking, sir, how are you? Right, I'm feeling okay, let me say that because obviously I'll have to take my classes starting from 7:30 almost. Session will be there till 12 o'clock, है ना? So let's see how I am doing. I'll be telling you how I am doing at the end of the session, मतलब almost around 12 o'clock. ठीक है? Me. So obviously, like I said, I'm also with 2 bottles of water here. I came super prepared, and the second bottle is a gift from Unacademy. I'm so happy for that. Okay, मेरे बच्चा लोग. Now, whoever doesn't know what happens here, here we are for the second part of our marathon series where we'll be discussing the chapter of magnetism, moving charges and magnetism, and magnetism and matter. Both these chapters will be completed in this particular session. When I say completed, we'll be discussing the concept, we'll be discussing multiple choice questions and assertion recent type question. Everything will be completed in today's session. So bachalo, who are seeing me for the very first time, this is Ameer, your physics educator at Unacademy. A bit of introduction about myself, I hope you all can see on the screen. I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board student. I'm a beta graduate from NIT Calicut, and this is all about me. One more thing, I'm from Kerala, मेरा बच्चा लोग, so I'm not so much good with the language of Hindi. ठीक है? So we'll be having all the conversation, most of the conversation in English, but बीच में थोड़ा थोड़ा हिंदी में भी बात करेगा. Okay, थोड़ा थोड़ा jokes भी मारेगा हिंदी पे. ठीक है? We'll make the session so much amazing and lively all the time. ठीक है? बच्चा लोग, this is what is happening right now. We already have completed electrostatics and current electricity. Those who haven't watched this, after the session, go and watch it. It will be very useful for you for your upcoming term 1 examination ka preparation. 7:30 right now we are dealing with magnetism, and at 10 p.m. we'll be continuing with the third part of marathon where we'll be discussing the chapter of EMI and AC. ठीक है? Okay, moving forward. If you don't want to miss the live classes from any of your favorite teachers, be a part of the Telegram channel, bachcha log, because all the updates will be given here in this channel. Link is given here and also in the description box. ठीक है? Bugs Bounty, it's a program which can help you to get prices. What you have to do, go to the description, there you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा prices मिल जाएगा अब सब लोगों को बच्चा लोग. Now, I want to ask you a small favor, not just for me, bachcha log, to all the students who's out there preparing for the term 1 examination, because I want every one of you, all of them to come here. Together we can prepare, and everyone, let's grab that 35 out of 35 marks. What do you all say? Palak, Ani, Shan, Sahil, Preeti, Shreya, Rushda, Bobby, Krishna. थोड़ा मुझे थोड़ा ही आता है हिंदी. ठीक है कृष्णा? Okay. Miara already shared, so everyone share the class and ask all your friends to come. ठीक है? जल्दी से जल्दी. In the meanwhile, बच्चा लोग, I'll explain about the Unacademy Plus subscription platform. Whoever is new here, okay? We'll use your friends can use this time so that they can come and join. ठीक है? Fine. बच्चा लोग, nowadays everything is available in YouTube. So why you have to pay some money and be a part of the Unacademy Plus subscription? There are so many reasons. I'll go with one by one. ठीक है? Now, there are so many students, right, who love to clear their doubts in the classroom itself, isn't it? Who love to have personal mentoring, who love to have personal guidance from the teacher. For these people, you should be a part of the Unacademy Plus subscription, because in the subscription feature, in the subscription platform, there is a feature called as in-class call facility. Matlab, in the class itself, you can call the teacher, okay, and ask the doubt and get it cleared whenever the teacher is taking the live classes. So isn't it the dream of all of the students to learn without any doubts? And that will be possible once you're a part of Plus subscription platform. Fair. Top educators of the country who's having a very good experience will be there to teach you. They'll be telling you the multiple choice questions, so you should be practicing. What are the multiple choices MCQ pattern you should be expecting? Everything they'll be telling you. You just want to follow them so that you can ace in all the examinations which you are preparing for and get into the colleges whichever you are dreaming about. Then study materials will be there, bacha log, practice test and live test series. All of this will make you super confident and will bring the best from every one of you, bacha log. So dekh le. If you go for 6-month subscription, hai na, bacha log, it will cost you 1,667 per month. And the entire physics family have this code along with us, which is AMB10. Use this code and get 10% of discount. So instead of paying 1,667, you'll only have to pay 1,500, and you'll get maximum offers also while you make the subscription. Okay? While you use the code. Iconic Pay, you'll get all the features of Plus some extra features such as personal mentor. Matlab, a person will be assigned to you. Okay? He'll be telling you how to study and what to study, and you'll feel so much comfortable when this person is assigned because he'll be there for all your academic activities 24/7. So you can study everything so lightly. Okay? Then live doubt solving classes, weekly reports. So for enjoying all these things, you can be a part of the Iconic subscription. Okay? 6-month subscription is more than enough. As we are at the academic year end, it should be costing you 2,833, but still you don't have to pay that much. Kyun? Kyun, bachcha lo, kyun? Code hai hamara paas, which is AMB10. Use this code and get 10% of discount. You only have to pay 2,550 rupees. Is everything visible there? Is everything visible? I hope so. Okay. Done. Now I think it's time for us to get started. Now I just want you all to tell me, are you all ready for this? Okay, once I wear chashma, it's a time for physics, hai na? Now you just tell me, are you all ready? Aaron sir, speak Tamil. मुझे इनके तमिल कुंजु दा तेरी. Okay, so bacha log, please take it seriously. I started my class from 3 p.m. till 5:30. We had our first class. Then I had a class in the platform from 6 to 7. Now I'm taking my class from 7:30 to 9:30 for this chapter, and EMI and AC from 10 to 12. So you just understand the pain of your bhaiya. So accordingly, I want every one of you to be serious. Okay, बहुत serious है. Take it so seriously with the fact that somehow together, right? You all together and आप सब लोगों का भैया, together we are going to crack that 35 out of 35. Are you all ready for this? Yokita, Jeet Singh, Shan, Noob, Ani King, Miara, Yokita, then Karthik, Satish, Preeti. Okay. So everyone is here with full of seriousness, Anna. So let's do it. Let's crack the term 1 examination and let's grab that 35 out of 35 together. Okay, starting. Let me tell you, bachalo, those who are very slow in writing the notes and all, you don't have to take down the notes because I'll be sharing the entire presentation and the PPT in the form of PDF in the Unacademy class 11th and 12th Telegram channel. Okay? So you can choose your way. Matlab, if you want to write the notes, it will be better, right? And if you want to take this particular notes from me, I'll be updating in Unacademy class 11th and 12th Telegram channel. Okay, let's start. Starting with the very first concept, which is magnetic field. Okay, 1 minute. I'll adjust the color and size of our pen where nothing is going to stop us. Okay, starting with magnetic field. Can you see this bar magnet, mere bacha log? Everybody of you can see, hai na? ठीक है. This space around the magnet. Can you see all the space around the magnet? This space around the magnet we simply define as the magnetic field. This is magnetic field और कुछ नहीं, right? The space around the given magnet is simply defined as magnetic field और कुछ नहीं, ठीक है? Now, what you all have to give stress on is what are magnetic field lines and its properties. Because from here we can expect the questions. ठीक है? देख ले. What are magnetic field lines? Answering you the very first part. Magnetic field lines matlab, right? The graphical way of representing the magnetic field at a point. Okay, so by the help of lines, we are going to express the magnetic field existing in the region, that is magnetic field lines. Now, if we take this particular bar magnet, as you can see, okay, which has a north pole and a south pole, The magnetic field lines are emerging from the north as you can see. It will be going it will be moving towards the south. Now, is it going to stop? Matlab, is the magnetic field line going to stop at the south pole? Bilkul nahi. Why? Because magnetic field lines always form closed loop. So inside the magnet, it will be moving from south to north. So this is how the magnetic field lines will be looking like for a given bar magnet. Between north and south, how will it be? From north, you can see that it will be moving towards south ऐसे, ठीक है? And it will be continuing south to north, and it will be continuing its, ठीक है, magnetic field lines. समझ में आ गया? Now, between north and north, you can see that magnetic field lines ऐसे, it will be repelling. This is how the magnetic field lines are going to look like for different arrangements of a given magnet. ठीक है? Now, one other thing that you should be knowing is, which is also common for our electric field lines, if we draw a tangent to the magnetic field lines, okay, if we draw a tangent, that tangent will be showing the direction of magnetic field at that point. If we have the magnetic field line, if we just draw a tangent to the magnetic field lines, that will be showing the direction of magnetic field at that particular point. It's very simple. The tangent drawn to the magnetic field lines give direction to the field at that particular point. First part is done. Let us read the other properties. The lines continuous, the field lines originate from the north and it will be terminating at the south pole, and inside the magnet it will be moving from south to north. We also have discussed this, right? Okay. Then they also form closed loops. This is also something which we have already discussed. है ना? ठीक है. More number of closed lines indicate stronger magnetic field. What does it say? Suppose you want to get the magnitude of magnetic field at a point. Matlab, how much is the amount of magnetic field at a point? For that, how can you understand? By looking at the magnetic field lines. I'll tell you. Let's go back. You know that close to the magnet, strength of the magnetic field is more. Just look into the magnetic field lines whenever you at the polar region. What can you see? You can see that the density of the magnetic field lines is more when it is closer to the polar region, which simply says, right, if the density of magnetic field lines are more, yes, the relative amount of magnetic field at that particular point is also more. Okay, larger magnetic field density, larger is the magnetic field value at that point. देख ले, here if you look at the magnetic field line का density बहुत कम है, मतलब ये कि the value of magnetic field at that point is also lesser out there. ठीक है? Very important point which we can apply it for both electric field lines and magnetic field lines, that they do not intersect each other, right? If they intersect, we know that magnetic field lines will be showing two different directions at a point, which is not possible. We all know this. We have learned in our regular classes. ठीक है? Now tell me, Vachalu, before we proceed, what's the difference between electric field lines and magnetic field lines? Electric field lines and magnetic field lines. Electric field lines originate from positive, terminates at negative, but magnetic field lines always make a closed loop. Fine. It is very important, note kar liye. Okay, that is the main difference between electric field lines and magnetic field lines. Here, closed loop. Dekh le. ठीक है? Okay. With a smile, we are going to proceed further. Now that was all about the magnetic field and magnetic field lines. Now we are going to learn how this magnetic field is related to the current and the current carrying conductors. Is there exists a relationship between current and the magnetic field? This is what we are going to discuss. And this was first found out in the Eastert's experiment. What was his experiment actually? Bachalo. He was having a current carrying conductor. I say, can you see this? Can you see this current carrying conductor? Near to the current carrying conductor, a magnetic compass was kept. He was so surprised to see that this magnetic compass started to deflect whenever the current was made to pass through this conductor. And then he made further research and understood that a current carrying conductor is producing a magnetic field around it. What is it? Once again. I'll just write it down. Dekh le. Okay. So what did I say? I said that a current carrying conductor will be producing a magnetic field around it. This is what was his conclusion in Eastert's experiment. Okay. Now, was he able to find out the magnitude of magnetic field? बिल्कुल नहीं. But he was able to understand the direction of the magnetic field produced by the current carrying conductor. How he found out? देख ले. Let's say this is the current carrying conductor. ठीक है? He found out that the magnetic field produced by this current carrying conductor is in concentric circles. Okay, and what is the exact direction of this concentric circles? For that, bacha log, take out your right hand. Everyone. Every bacha logs here in the classroom, hai na? Every bacha log. Bacha log, voice is clear, right? Is my voice clear? Voice clear है ना? बिल्कुल clear I suppose. Yes, okay. So I was just clearing it. ठीक है. Now देख ले. Now, how to find out? Everyone listen. How to find out the direction of magnetic field produced by current carrying conductors? That is with the help of a right hand thumb rule. I'll write it here. A right hand thumb rule. Okay. How can we make use of it? Take out your right hand, everyone. Okay. Keep your thumb in the direction of current carrying conductors. Can you see that? Can you see that? Done. Hai na? Now curl your fingers. Start curling your fingers. So the direction of the curled fingers will show you the direction of magnetic field produced. So what is the curled fingers showing you? It is showing you an anti-clockwise circular direction. Hai na? ऐसे. Isn't it showing a direction like this? इधर से बाहर आ रहा है ना? So this is how you find out the direction of magnetic field. So just keep your thumb in the direction of current, curl your fingers, whatever is the tip of the finger showing at each point, that will be showing the magnetic field at that exact point. देख ले? So keeping your thumb at this particular point, let me mark it as point X. In which direction the fingers are pointed? Inside, है ना? You can see it is inside. So at this point, the direction of magnetic field is inside. So if you want, I can write it. Inside. Similarly, at this point, let's say Y. What do you have to do? Keep your thumb, curl your fingers. What can you see? Look in the video. The curled fingers are coming outward. So at this point, the magnetic field is outward. समझ में आ गया? So don't forget this because you will be getting questions from these kind of topics. ठीक है? समझ में आ गया? Fine. Moving on, everyone, moving on. Now, in the previous case, we were discussing about direction of magnetic field produced by current carrying conductors. So, someone has to come up with a new law which talks about the magnitude of magnetic field produced by current carrying conductors. मतलब numerical value. That is explained in Biot-Savart's law. Shall we look into the equation? ठीक है, देख ले. We have an XY current carrying conductor. It carries a current of I. Consider a small length in this entire current carrying conductor and let us mark it as DL. Okay, a small length we have considered from this current carrying conductor. Let's say DL. We have a point P here and let me draw a line from the small length of the conductor to the point P. An angle is formed by this line with the current carrying conductor. Let me mark it as theta. The distance to the point P, let us mark it as R. According to Biot-Savart's law, the magnitude of magnetic field, the small magnetic field dB produced at this point is given by the formula of mu naught by 4 pi I, the current, dl, the length of the conductor we have considered, sine of ye theta divided by r square. This is the perfect example or the perfect equation which gives us, right, to find out the magnetic field produced by a current carrying conductor at a distance of r. Very important, write it down. Those who are making the short notes in the class, jaldi se write down kar le. हो गया? ठीक है. Now I'll explain ये mu naught क्या है. Mu naught is called as permeability. Okay, Permeability means how easily a given medium can be magnetized. If permeability value for a medium is more, that medium can be easily magnetized. That's what it means. And value of mu naught by 4 pi is equal to 10 power minus 7. Okay, numerical value of mu naught by 4 pi is 10 power minus 7. Your mu naught है ना, permeability of space या atmosphere होता है. Okay, now if you are finding out the magnetic field in some other medium where the permeability is mu, in that case the formula will be mu divided by 4 pi I dl sin theta by r square. बोल दे ये क्या है? Now here we have used mu because this is a case we have to do when we are finding in a different medium, right? We are finding out the magnetic field in a different medium. Formula for magnetic field is mu by 4 pi. Mu क्या है? Permeability of that medium in which we are finding magnetic field. ठीक है? Done? Okay, done. So इधर तक clear है? One last thing related to mu and mu naught. Let's say mu is the permeability of a given medium. Mu naught is the permeability of space or air. Your ratio है ना, we call it as a relative permeability. Mu by mu naught is called as a relative permeability. Another important concept. Mu divided by mu r is a relative permeability. Right कर ले सबने, ठीक है? हो गया? So I'll just show what all things we have written till now. Fine. So we are going to proceed further. Now we are going to find out the value of magnetic field produced by an infinitely long current carrying conductor. देख ले. So this is a current carrying conductor. It is infinitely long to the upper portion and to the bottom portion. ठीक है? Now question is how to find out the magnetic field at a point P which is at a perpendicular distance of r from it. Formula mu naught divided by 4 pi 2i divided by, here a is used, so let me also use a, 2i by a. We are not going for the derivation because obviously we are going for MCQ series and MCQs, assertion, recent type and case study. We don't need the derivation for this. So the value of magnetic field is mu naught by 4 pi 2i by a. So this 2 and 4 can be cancelled and you can write it in this manner also. But I usually prefer with this general thing, mu naught by 4 pi 2i by a. ठीक है? So this is what I prefer. Up to you, whichever you want to, you can use those equation. But by heart जरूर कर लेना. I want every one of you बच्चा to by heart this. ठीक है? Proceeding. Now similarly, by using the same Biot-Savart's law, finding out the magnetic field by a current carrying loop. We have a circular current carrying loop of radius r. Along the axis passing through the center, we have a point P which is at a distance of x from it. Okay? Now the value of magnetic field at this point, instead of this formula, the formula which I prefer is mu naught divided by 4 pi, okay, 2 pi I r square the whole divided by r square plus x square the whole power 3 by 2. This is a formula which I prefer, right? That 2 pi and 4 pi can be cancelled and written as 2, and you can by heart this formula also, but up to you. But I usually prefer the one with that general term of mu naught by 4 pi. Okay, so this is to find the magnetic field at a point P which is at a distance of x along the axis. Okay. Now my question, bachcha log, everybody answer in the chat box. By using this formula, can we find out the magnetic field produced by this current carrying loop at the center of the loop? Is it possible? बोल दे, आप ही बोल दे. आप ही बोल दे, is it possible to find the magnetic field at the center? Yes, it is totally possible. Chandan, Nivek, yes. Raki, yes. Definitely. What you have to do? Okay, you all have said yes here. Now tell me what I have to do. X is the distance to the point, right, from the center to the point P. So if we are considering the center point itself for finding magnetic field, x का value कितना है? x 0 होता है ना? So put x equal to 0 here. कितना हो जाएगा? Mu naught divided by 4 pi 2 pi I r square by r square plus x square is 0. So r square the whole power 3 by 2. Square and 1 by 2 cancel, it is r cube. This is magnetic field at the point O. This cancel, mu naught 4 pi and cancel, mu naught by 2 I. This is B naught. Magnetic field produced at the center of a circular loop is given by mu naught I divided by 2R. Very important. Very important बच्चा लोग. Okay, clear with a smile. I hope you all are writing it down. ठीक है, समझ में आ गया? ठीक है. Hi, good evening, good evening. Good to see you, कोहली जी. Okay. So हम जा रहे हैं to Ampere Circuit Law. First question: why we have this Ampere Circuit Law? To find out the magnetic field in a much easier way produced by current carrying conductors. Okay. What does it say? If you are having a current carrying conductor, let's say we have a current carrying conductor. In order to find out the magnetic field which is at a distance of r, Ampere Circuit Law tells you just to consider a closed loop passing through that point where you want to find magnetic field. So here I am considering a circle. Do you know what's the reason I consider a circle? Simple reason. Because the Amperian loop which we have considered and the direction of magnetic field will be the same. Magnetic field produced by a current carrying loop is also circle. Both will be correspondingly having the same direction. Then the Amperian Circuit Law tells you integral B dot dl is equal to mu naught times the current it encloses. Line integral of magnetic field over this entire Amperian loop we have considered will be equal to mu naught times the current enclosed by the loop. मतलब क्या? I'll just explain you. Current enclosed by the loop क्या आता है? देख ले. This is one current. Let's say this is 1 ampere. This is ऊपर. This is 2 ampere. Downward we have minus 5 ampere, and one more is there. Let me say this is 3 ampere upward. Question is, this is our Amperian loop. Okay? This is our Amperian loop which I have circled. Question is, what is integral B dot dl? Question is, what is integral B dot dl for the Amperian loop we have considered? How will you write? Mu naught times current enclosed. है ना? How much is the current enclosed? 1 ampere ऊपर, 2 ampere ऊपर. So that is 3. Plus 5 ampere is नीचे, so minus 5. So mu naught minus 2i. है ना? समझ में आ गया? So this is how you find out the current enclosed in an Amperian loop. Does 3 ampere have any influence in calculation of integral B dot dl? बिल्कुल नहीं. This is out of our thing. We don't need it. हमको नहीं चाहिए. भाग जाओ 3 ampere, भाग जाओ. Okay? हमको चाहिए 1 ampere, 2 ampere and minus 5 ampere. बस और कुछ नहीं. ठीक है? समझ में? मुस्कुरा ले फिर. Okay, so इधर तक clear है ना सबको? Okay, now let's see how we can make use of this equation to find out the magnetic field at this point. Very simple, we'll do a derivation है ना? देख ले. As all the points on this Amperian loop are at equal distance from the current carrying conductor, magnetic field constantly हो जाएगा B outside. Integral dl is equal to mu naught times current. B into integral dl, if you integrate the entire length of this Amperian loop, क्या मिल जाएगा? Circumference, है ना? The entire circumference of this Amperian loop which we have considered, that is 2 pi r, that is mu naught I. B is equal to mu naught by 2 pi I by r, multiplying 2 mu naught by 4 pi. देख ले, whatever we have learned some moments before, we have just proved it so simply. How? So simply by using the concepts of what? Amperian loop. समझ में आ गया सबसे, सबको अच्छे से समझ में आ गया? हाँ हाँ हाँ, न्यूमेरिकल्स ही ज्यादा हो जाएगा मेरा बच्चा मनप्रीत का, ठीक है, बहुत ज्यादा हो जाएगा न्यूमेरिकल्स, ठीक है। सो हम जा रहे हैं, ठीक है। सो बाय यूजिंग सिमिलरली द कॉन्सेप्ट ऑफ एम्पियरियन लूप we can find out the magnetic field of a solenoid also, ठीक है। What is the value? The magnetic field of a solenoid is mu naught Ni at the center. सबको पता है ना solenoid क्या होता है? I think I don't need to explain ये solenoid क्या होता है, right? Circular turns which is turned over a length, ऐसे 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 ऐसे, and if we pass a current through the solenoid, magnetic field is produced inside the solenoid. If you are finding magnetic field at the center है ना, formula for magnetic field is mu naught छोटू n into I. पूछ ले सर ये छोटू n क्या होता है? Total number of turn, let's say it is n. The length of the solenoid, let's say it is L. ठीक है, so छोटा n is equal to capital N divided by capital. मतलब क्या है? Total number of turns per unit length होता है छोटा n. Similarly, at the end points, can you see this point? If you want to find the magnetic field at this end point, formula is mu naught small n I. At both the places it is small n I. So mu naught small n I by 2 where? At the end, at the center, mu naught mu naught n I. ठीक है? Okay. Moving on. Toroid क्या आता है? What is toroid? I'll just tell you. Can you see this solenoid which we are discussing? Right? This solenoid, okay, just like who's more powerful, just like a Superman, okay? Give the entire force and rotate it and make into a circular form. ये solenoid है ना, just bend and make into a circular form. What do you have is called as a toroid. और कुछ नहीं. What do you have is called as a toroid, okay? Now, magnetic field at this point and magnetic field at this point, मतलब inside the center, outside, magnetic field 0 हो जाएगा for a toroid, ठीक है? Magnetic field exists only at this region of the toroid where the windings are like this, ठीक है? Magnetic field is given as mu naught capital N I divided by 2 pi r. R क्या होता है? ये the average diameter of the toroid. Okay, mu naught capital Ni by 2 pi r. Sometimes you can write it as mu naught capital N by 2 pi r is written as small n. This is also possible. This is the magnetic field produced because of a toroid. So आप सब राइट कर रहे हैं ना सब लोग? बच्चा ना पूरा का पूरा बच्चा लोग, ज्योति, निसार, अरे बच्चा रुकिए, निसार, others, are you having the problem with my voice? Nisar, one of my student is telling usko he is not able to hear me. Is everything fine? Can you all hear me? Yes, can you all hear me? No problem, it's okay, right? Beep sound coming, 1 minute. Let me see. Nisar, one of my students is telling usko he is not able to hear me. Is everything fine? Can you all hear me? Yes, can you hear me? देख ले, in my phone I am able to listen it in a very perfect way. No problem, it's okay, right? Beep sound coming, 1 minute. अब ठीक हो गया है ना? सब अरे सब अच्छा है, सब अच्छा है मेरा बच्चा लोग, ठीक है? हम इधर है, आपका भैया इधर है, कोई बीप साउंड कुछ भी नहीं आएगा। आने भी नहीं दूंगा क्योंकि हम लोगों को पढ़ना है, ठीक है. So we'll do it in a very perfect way. Shall we proceed? Fine. Okay. So toroid is done. Next, the force experienced by charged particle in a magnetic field. Matlab, let's say if you are having a charged particle Q which is having some velocity V, it's moving and it is in a region of some magnetic field B where the angle between them is theta. Now, the amount of force it experiences is given by the formula of Q V vector cross the magnetic field vector. Q the charge, V velocity vector, and B the magnetic field vector. How can you expand it? QVB sin theta is the magnitude. V cross P. Now, पूछ ले चलो how to find the direction. ठीक है, मतलब I'll just tell you. Let's say we have a magnetic field at a region which is inside. Inside magnetic field, cross matlab inside. There is a charge Q which is moving towards right. Okay. Question: what is the direction of force experienced? How will you find out? Everyone make use of Fleming's left hand rule. Matlab everyone take out your right hand. Sorry, अरे बाप रे. Take out your left hand. ठीक है, ले लिया. Everyone stretch out all these three fingers. Thumb, index and middle finger. ले लिया. ठीक है. Now ये index finger है ना, keep it in the direction of magnetic field. कर दिया. ठीक है. Middle finger in the direction of velocity. कर दिया. The thumb will be showing you the direction of force it experiences. So what is the direction of force? Now we have in this case upwards. Okay, so the direction is being found out by Fleming's left hand rule, FLHR. Fleming's left hand rule, I hope you all know, right? Index finger in the magnetic field, middle finger in the direction of velocity, thumb will be showing you the direction of force it experiences. Simple. ठीक है, हो गया, magnitude भी हो गया, direction भी हो गया, ठीक है. Moving on. Now, let's say this moving charge है ना, it is kept in a region of both electric field and magnetic field, दोनों है. Okay, this charge it is moving, it is kept in a region of both electric field and magnetic field. So what is the total force? It will be experiencing a force of electric field, Q in electric field, plus there will be a force experienced because of magnetic field present. So total force will be equal to QE vector into QV cross B vector. Fine. Another important fact. ठीक है, हो गया है ना, ठीक है. So I'm proceeding. So this total force है ना, this total electric force plus magnetic force, उसका नाम है Lorentz force. The sum total of electric and magnetic force acting on a charged particle, नाम क्या दे दिया हमने? Lorentz force. नाम है डॉन नहीं, Lorentz force है इधर. Now, motion in electric field. Without me telling, you all know, who have opened the NCERT textbook might be knowing. है ना? देख ले. A charged particle Q is moving with some velocity V towards right. There exists a magnetic field inside. Tell me what is the kind of motion this charged particle is going to have if it enters into a region of perpendicular magnetic field? बिल्कुल. It will be making a circular motion like this. Yes or no? है या नहीं? है या नहीं? बिल्कुल. Isn't it? Yes. So it will be making a circular motion. Questions can be, what is the radius of the circular motion? कितना होता है? mv by qb. Formula for radius of this particular motion is m, mass of the charge, velocity, the speed with which it moves, q charge, b magnetic field. Questions. What is the time period? 2 pi m divided by qb. This is the time period, matlab time required for completing one circular motion. This is time period. This is also important. Rest of the things you can derive. Let's say frequency 1 by time period. सब कर सकते हैं आप लोगों को. Okay, omega, that is v by r, that is qb by m. I think you all can do that just by rearranging the things. ठीक है. This is not the case. मतलब if it is entering perpendicular, in this previous case देख ले, velocity is in this plane, magnetic field is inside. मतलब B and V are perpendicular to each other if it is making a circular motion. ठीक है. In that case, radius and time period का value भी we have written. But there exists a magnetic field towards x-axis, okay? And the velocity of the charged particle is making some angle theta. Either it's not a perpendicular. What kind of motion? Here it will be a combination of circular motion and linear motion. Tell me what kind of motion? I'll just look into the chat box. आप ही बता दे चलो. What kind of motion? अरे Rajput. Helical motion, Chandan, very good, baap re, amazing. Very good. So Riya, Bobby, Chandan, Shrikant, Abhilasha, Supriya, Cook the Cookie. Cook the Cookie is also there in this class. Very good, Cook the Cookie. Okay, I personally don't know the person. I just met him or her in the last class only. The name is really catchy, है ना? Nok, Shreya, Riya, Prakar, Yokita, Supriya, Suhani, Palki, Miara, Nikhilendra, Jodi. Good. So we can have a helical motion. So for this, let us take the component. है ना? देख ले, we'll be having two components of velocity. V cos theta ऐसे and V sin theta ऐसे. Fine. Now, with this V sin theta, the particle will be making the circular motion, and V cos theta will make the charged particle to move further. So we can see an helical motion like this. S. Fine. In this case, questions, what is the radius? Formula, is it mv by qb? No, because the velocity with which it is making the circular motion is not entire v, it is with v sin theta. So radius is m v sin theta by qb. ठीक है, but time period कोई difference हो जाएगा नहीं, because in the equation of time period there is no influence of velocity. देख ले, we don't have velocity in time period, so time period in the normal case and in this case same here, 2 pi m by qb. One more thing, this horizontal distance the charged particle makes in one circular motion, uska naam hai pitch. We call this as pitch. Anybody have an idea how to find out this pitch? Very simple. The particle is moving in the horizontal direction with v cos theta. Okay, so pitch will be equal to v cos theta multiplied by the time taken for one complete circular motion, time period. So pitch formula is v cos theta into time period. If you want to substitute for time period, you can do that. हो गया ये. Motion and an external magnetic field भी हो गया बच्चा लोग. हो गया तो हो गया. Okay, अब क्या बाकी है? So we have some more topics. जल्दी से finish करेगा ना? We'll complete this, then we'll start MCQ. What do you all say? Next chapter is Chotu only. Most of the portions are deleted. Yes, clear. Shreya, Tushit. Okay, ठीक है. Next is cyclotron. What is cyclotron? It's a device which is used to accelerate the charged particles. How? With the combined effect of electric field which is existing in between these two D portion, उसका नाम है D's. In between the region of D's we have electric field, and in this D portion we have magnetic field. And how the charged particle is accelerated? Charged particle is kept in between the D's, which is accelerated with the help of electric field, because it will be producing a force on the charge QE. It enters into the region of magnetic field where it undergoes the circular motion. Acceleration हो जाएगा ऐसे, it will keep on increasing the radius, and finally it will be out from this particular cyclotron with an enormous amount of velocity. Questions can be, what is the velocity with which it ejects out? You don't have to learn any new formula from here. देख ले, radius is mv by qb, circular motion कर रहा है, ठीक है. Velocity का formula qb by m into radius. Okay, tell me which radius we have to use here. Just before the particle is ejected out, it will be having the maximum velocity. Just before it is projected out, what is the radius of the charged particle? The radius of this d, है ना? So if you mark the radius of the d as r, ऐसे, so maximum velocity is equal to maximum radius in which it is making the circular motion into QB by M. बस हो गया. This is the question. Question can also be kinetic energy. If you have Vmax, kinetic energy is not an issue. Half mv square. ठीक है, हो गया. Then time period and frequency remain the same. It does not depend upon velocity, as I have already told you. Time period is 2 pi m by qb. Frequency, which is the inverse of time period, qb by 2 pi m. ठीक है. ओके, ठीक है, हम जा रहे हैं. साइक्लोट्रॉन भी हो गया. नाउ force experienced by a current carrying conductor. पूछ ले बच्चा लोग. You can ask me, sir, does a current carrying conductor experience a force? If a moving charge can experience a force in magnetic field, current carrying conductor, which is the collective flow of all the charges, can't it experience a force? बिल्कुल. Formula for force, not Q, अरे बाप रे. Formula for force experience is given by the formula of I, L vector cross the magnetic field vector. Very important. I, L is the length of the current carrying conductor and V is the magnetic field existing in this region. So if you want the magnitude of the force, I, L, B sin theta. You can ask me, sir, ये theta क्या होता है? Let's say the magnetic field in the region is B. This is the direction of current carrying conductor. Can you see an angle between them? वो होता है ये theta. ठीक है. Then और क्या है? पूछ ले. Direction. How? Very simple. Once again, Fleming's left-hand rule. So for finding out the force on charge and for finding out the force on current carrying conductor, same rule. Fleming's left-hand rule. Let's find out. देख ले. So this is our current carrying conductor. There exists an insert magnetic field. Question can be, what's the direction of force? Take out your left hand, everyone. Stretch out all these three fingers, which is thumb, index and middle. Index finger keep in the direction of magnetic field. Here it is a cross, so magnetic field inside. Middle finger in the direction of current, that is towards right. So the thumb is pointing upward, which will be showing the direction of force. So this also Fleming's left hand rule. हो गया? No doubts, I suppose. ठीक है? Written Fleming's left hand rule, everyone. Proceeding further. Everybody is using that chota form, shortcut FLHR. Okay. Now, if you are having two wires, where currents are moving in the same direction, where the current are I1 and I2, there exists an attractive force. Currents are in the same direction, force is attractive. So the force experienced by either of the conductor per unit length, F by delta L is force per unit length experienced by either of the conductor is equal to mu naught by, I usually write it like this, mu naught by 4 pi 2 I1 I2 divided by R. You can ask me, so mu naught by 4 pi, everybody knows, 2 product of the current in both the wires by R. देख ले R क्या है? The perpendicular distance between this current carrying conductors. Bas. So there exists attractive force between them. Questions can come like this. Current is moving upward, this current is moving downward. What is the direction of force? Is it attractive? No. If opposite, the force will be repulsive in nature. Okay? Same formula, but the direction is only difference here. That's all. Magnetic dipole moment, very important concept. Okay? Dekh le. Everybody. Let's say here we have a bar magnet, a north and a south. Compare this to a electric dipole. Okay? So here in the case of electric dipole, we have charges to express the strength of the poles. Okay? So the quantity which express the strength of the pole of a given bar magnet is pole strength. क्या है ये? Pole strength. Unit ampere meter. Plus m to represent north pole and minus small m to represent the south pole. Let's say the distance from south to north is 2l. Here we have a new quantity which we call it as magnetic dipole moment, which is a vector. Same, what is electric dipole moment? Q into 2l. Magnetic dipole moment, m into 2l vector, because it's a vector. From here, negative to positive. Similarly, for this, south to north. The direction of magnetic dipole moment for a dipole is from south to north. Very important. Written? हो गया? Smile से. Smile हो रहा है ना क्लास पे? ठीक है, ठीक है, ठीक है. I hope you all are noting down and with a smile. I don't want anyone to be having that tired wala face या what's a stress wala face. Exams आ जाएगा ऐसे ही हम we'll be solving all the questions and we'll be coming out of the exam hall also. ठीक है? शिवम, दीपिका, योगिता, चंदन, ज्योति, मेघवर्षिनी, Animesh. Okay, ठीक है. I can see the smile from all my amazing great बच्चा लोग. Okay, so Sudeep is having the biggest smile and lot many smiles there. ठीक है, बढ़िया बात है, बढ़िया बात है. अरे PDF जरूर मिलेगा चंदन in the Unacademy class 11th and 12th Telegram channel. I'll be sharing the link PDF. ठीक है. Now it is found out that ठीक है, a current carrying loop is also acting like a magnetic dipole. North and a south pole bar magnet, we call it as magnetic dipole. So a current carrying circular loop will also be acting like a magnetic dipole. ठीक है. Questions can be, first, what is the value of magnetic dipole moment? Let's say it has n number of turns. So magnetic dipole moment is NIA. N number of turns, I current, A is area of the circular loop. ठीक है. Then how to find the direction? Right hand thumb rule. If you want to find the direction of magnetic dipole moment, right hand thumb rule. Take your right hand, curl your fingers in the direction of current. Did whatever is the direction of thumb, that is the direction of magnetic dipole moment. In this case, it is outward. मतलब M cap is plus K cap. Plus K cap मतलब outward in the Z axis. ठीक है. Magnitude, direction. Magnitude, direction. ठीक है. Awesome. Okay. Moving on. So this we have already discussed right now. Torque on a current carrying loop. बच्चा लोग याद है आप लोगों को that a positive charge and a negative charge, right? If it is kept in an external electric field, will it be experiencing a torque? Obviously, formula is electric dipole moment cross the electric field. Similarly, if we are having a bar magnet of north pole and south pole, this will also be experiencing a torque when it is kept in an external magnetic field. Formula similar. Here it is electric dipole moment into electric field. Here हो जाएगा magnetic dipole moment into magnetic field. बस ठीक है. And if instead of bar magnet, if we are having the current carrying loop, the torque formula will be equal to current carrying loop. What is the value of magnetic dipole moment? NIAB sine theta. Why sine theta? Cross product. Fine. Instead of bar magnet, if you are replacing it with a current carrying circular loop, magnetic dipole moment is NIA into B sine theta. बस आ रहा है समझ में तो आ रहा है. Okay, so torque value we already have discussed. Now, okay, fine. ये भी ले ले बच्चा लोग, ये भी ले ले. Magnetic dipole moment of a revolving electron. Just now we have seen a current carrying circular loop produces a magnetic dipole moment. Current carrying loop matlab flow of charges. So similarly, if a single electron is also making a circular loop, it will be producing a magnetic dipole moment, and the amount of magnetic dipole moment is E, electronic charge, velocity with which it moves, the radius with which it moves divided by 2, EVR divided by 2. ठीक है, write it down. Okay. Galvanometer. Chalo, we are at the end of the chapter. Done. Last topic. Galvanometer. फिर we'll start with MCQ time. कितना हो गया? अरे 8:25. कोई बात नहीं. What is galvanometer? It's an instrument which we use to measure small amount of current or small voltages. ठीक है. What is the basic structure? It will be having a current. It will be having circular loops like this. Obviously, loop will be having two ends. It will be kept in external magnetic field. देख ले. Now, whenever this galvanometer is connected to some external circuit, क्या हो जाएगा? Current will pass through this. When current pass through this loop is kept in an external magnetic field. This will start experiencing torque. है ना? This will start rotating. है या नहीं? This will start rotating. So the needle is connected to this particular ring here, right? So the needle will also be rotating along with the rotation of this particular coil, which will be showing the necessary amount of current in the dial. This is how a galvanometer works, just on the basis of rotation of a current carrying coil in an external magnetic field. So the torque it experience formula NIAB, है ना? Now, in order to stop this particular coil during the time of rotation, it will be connected to a spring. Can you see this? It will be connected to a spring, right? If it rotates, spring is also rotated. So if spring is rotated, क्या हो जाएगा? Restoring torque is developed. If C is the restoring torque developed per unit difference, C theta will be the total torque. This is NIAB. Okay, so the angle of deflection theta will be given by the formula of NIAB. Okay, two more things, question can come. Those who have done the sample paper, you might have seen this. ये I है ना, take it to the left hand side. Theta by I is equal to अरे C बाकी है, C है. Okay, so NAB by C. If I take this I to the left hand side, what we have? Theta by I. ये theta by I क्या होता है? अरे theta by I is current sensitivity. Tell me, have you all seen this बच्चों? Have you all seen this? ये current sensitivity, theta by I, question in sample paper. हाँ, Bobby Kumari already gave me. Yes, Sabra. Yes, Raki, Chandan, Agansha, Nokshi. है ना? So this is it. ठीक है? Okay, very good. So I think you all do remember here. So current sensitivity theta by I is NAB by C. What do you mean by current sensitivity? The angular deviation in the needle per unit amount of current. मतलब if you give 1 ampere, how much is the deviation in the needle? That is current sensitivity. Similarly, we have voltage sensitivity, that is theta by V. Voltage sensitivity. So V is IR. ठीक है? Theta by I already we have the formula of NAB by C, 1 extra R. This will be the formula for voltage sensitivity. ठीक है? Very important. Done. This is over, right? No doubts? I think yes, that's it. I think this was one of the biggest chapter we have ever seen. Electrostatics also we have completed faster than this, but this was a bit bigger. Magnetism and matter after this chapter right now we are going to do. Don't worry. No. Earth magnetism is not deleted. Earth magnetism is there. Okay. Shall we मेरा चलो? We'll try to finish this class by 9:30. Okay, so tell me, what is the answer for this? Everyone go for the question. It's a simple question है, छोटू सा question है. Sana, Deepika, Tushar, Palak, Muhammad Aslam, Abhilasha. Okay. I'll talk about, we'll do the multiple choice question here. Then we'll talk about conversion of galvanometer to ammeter and voltmeter. ठीक है? we'll do it, कोई बात नहीं, we'll discuss all the topics. Okay Chandan, you gain confidence, और क्या, everyone here in the classroom should gain confidence. Answer? Answer. Everybody is going for option B. Anshika, AS Tech is B, Sabra with B, Bobby B, Deepika B, Mithilesh is with A, Sana is like A or B. Okay. So let us do the problem. The correct answer is option A मेरा बच्चा लोग. Let's do it. It's very simple. Very simple है. देख ले. A long solenoid has 200 turns per centimeter, fine, and carries a current of I. The magnetic field at its center is 6.28. So let us write. Magnetic field is equal to 6.28 into 10 power minus 2 for a given solenoid. What is the formula? Mu naught N I. This is 6.28 into 10 power minus 2. Mu naught N कितना बचा लो? N कितना दे दिया? 200 into I is equal to 6.28 into 10 power minus 2. We are not converting centimeter to meter because here we are only doing the ratio. So in the second case also it is per centimeter. So दोनों cancel हो जाएगा. So there is no need of converting again and again and making this question complicated. ठीक है. Question is, देख ले, another solenoid has 100 turns. Here it was 200. Here it is 100 turns. ठीक है. Centimeter, and it carries a current of I by 3. Value of magnetic field. In this case, what is the value of magnetic field? B dash. Same formula. Mu naught N I. है ना? Mu naught. Number of turns is 100 per centimeter. So I'm going to write it as 200 by 2. ठीक है ना? 200 by 2 is 100 itself. Right? For easy comparison, I have written as 200 by 2. ठीक है. And I is I by 3. है ना? Current I is I by 3. ठीक है. Mu naught into 200 into I. Mu naught into 200 into I. How much is the value? Mu naught into 200 into I. 6.28. 6.28 into 10 power minus 2. The whole divided by 6. कितना हो जाएगा? 6.28 by 6. 1.05 into 10 power minus 2. और क्या? This much of Tesla. Simple. Simple, dimple, है ना? Symbol भी है, dimple भी है. और क्या? समझ में आ गया ना सबको? समझ में आ गया? Is it clear? जल्दी बोल दे. स्टाइलिश रजपूत आप जा रहे हैं? स्टाइल जाएगा हमारा क्लास से. Okay. Yes, Supriya. So take a screenshot because we are moving for the next question. अगला क्वेश्चन, अच्छा वाला क्वेश्चन है. Go for it. Yakita, Palak, Sana, Abhilasha, Myara, everyone. Awesome. मेरा बच्चा लोग जल्दी जाइए सबने. And go for the next one. ये question. I'm waiting for the answers here. Okay, Mithilesh have given me the answer here. Option C बोल रहा है. Mansi Gupta, sir, I find physics very difficult. Session पूरा attend कर ले, you'll find it so easy. Late हो गया Sana, so please do watch the replay. Okay. Myara C और A, Rahul B. Then Muskanpreet C, Rahul B, Ashish B. ठीक है. So I can see a mix of option between B and C. लेकिन हमारा correct answer option B है. Let's start doing. Two conductors separated by D carrying current I1 and I2. The force experienced on each other is F. Tell me, what is the formula? I1, I2, same direction, separated by a distance of T. force per unit length formula mu naught divided by 4 pi 2 I1 I2 divided by d, है ना? This is the initial force, okay, and this force per unit length is given as F, ठीक है? Question क्या है? Now the current in one of them is increased to 2 times and direction is reversed. देख ले. So I1, let us keep it as such. In the second wire, the I2's direction is being changed and made the value 2 times. So 2I2. Okay. So as it is in the opposite direction, we'll put a negative sign. Minus 2I2. Okay. Distance is increased to 3D. Now this distance is 3D. So here force कितना हो जाएगा? Formula mu naught divided by 4 pi 2 I1 I2 कितना? Minus 2 I2 whole divided by distance. How much? 3D. I'm taking this, देख ले, ये minus 2 and ये 3 to the first portion, minus 2 by 3 mu naught divided by 4 pi I1 I2 by d. खत्म. देख ले, minus 2 by 3, ये देख ले, ये देख ले, ये 2 इधर है, ठीक है, ये 2 इधर है, मैं भूल गया ये राइट करने के लिए, I forgot, ये 2 इधर ही है. So this is F. So the new force F dash is minus 2 by 3F. Okay. डन 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 डना डन बच्चा लोग. Yes, Chandan, Mithilesh, सब है ना? Meghavarshini, what do you feel right now? What do you feel right now, बच्चा लोग? Are you feeling more confident? बिल्कुल होना ही चाहिए, है ना? With a smile, tell me, yes sir, I feel so much confident right now. Okay, let's do this problem. Okay, I won't be completing the entire mathematics here. I'll be leaving the mathematics for you. We'll be just doing the calculation, the method. Energize Himanshu, very good. Energetic. Okay, waiting for the answers right now. देख ले, everyone. I'll just sit here until you give me the answer. इधर ही बैठूंगा मैं. कूल मुंडा, अरे कूल मुंडा आईफोन कैसे, वो तो जरूरत का काम भी नहीं हो जाएगा आपको. So ask me sir how to do the problem. So that will be coming to your help. Answers. So I can see the option C by Aditya. Then Achalok, Hani is giving the option C. Good. Sabra is with C. Then Muskan, Rahul, Manju, sub C दे रहा है. Very good. Very good. Very good. Very good मेरा चलो. Shall we? देख ले, two insulating infinite long conductors carrying current I1. This is 2 ampere. I2 4 ampere. Mutually perpendicular to each other. मतलब they are perpendicular ऐसे. Find the magnetic field at this point P. Very simple. How to find out the total magnetic field? First, we will find out the magnetic field produced by current I1. Then we will find out the magnetic field produced by I2. Add them vectorially, you will get the answer. Shall we? We'll go step by step. Magnetic field produced by the first current carrying infinitely long conductor. Formula mu naught divided by 4 pi. Right? Formula is mu naught by 4 pi 2I by R. है ना? Those who don't know. Now let me substitute and write. 2 times I कितना? What is I1? I1 is 2 ampere. 2 divided by what is the perpendicular distance to the point P from the current carrying I1? 4. That is 4 into 10 power minus 2. Vector या scalar magnetic field vector direction is important. How? Keep your thumb in the direction of current. Curl your fingers. You can see that fingers are showing downward direction. है ना? बिल्कुल हाँ बोल दे. Yes. So downward direction मतलब minus k cap. Magnetic field produced by the second conductor I2. Formula same. mu naught by 4 pi, 2 times the current it carries, what is I2? 4, divided by the distance, perpendicular distance from I2 to the point is 3 centimeter, that is 3 into 10 power minus 2. Direction, important. Keeping your thumb towards right, curl your fingers, what you can see, chalo, it comes outside, hai na? So outside matlab plus k cap. So how will you find two magnetic field? Vectorially add magnetic field vector V1 and V2. One is plus k, minus k. Added, obviously subtraction is going to happen. Final answer is 1.66 into 10 power minus 5. This is the final answer you are going to receive. Option C. Okay. I am leaving that addition part to you all. Okay. Now I'm going to ask you, chalo. Now I'm going to ask you, right, how many of you want to do some assertion recent type question? किस किस लोगों को करना है assertion recent type? किसको भी नहीं और करना है? We'll do one assertion recent type, then we'll go to the next chapter. Perfect. Yogita, Ani, Miara, Himanshu, Supriya, Chandan, Raki, everybody want to do? Okay. So I think one of the Arpan Bhaiya is here to give all the best for the 12th exam. Okay. बच्चा लोग आप ही कर ले. For this question, I don't think I'll have nothing to explain here because everything is given here. So I'm just sitting and waiting for your answers. And after this, we'll be starting with magnetism and matter. ठीक है? Answer आप ही दे दे. Sir can't see. किसको नहीं देख? अरे ये है ना? हो गया. अभी हो गया ना? Now you all can see. Answer? Mithilesh is giving B. Miara is giving B. Himanshu A बोल रहा है. So Asta is giving for A. Mahak is with C. Aditya C. Sabra A. Okay. So I can see a mix of options, है ना? D, B. Okay. So हमारा correct answer option A. Simple. In electric circuit, wires carrying currents in the opposite direction are often twisted together. Okay. Now, if it is not twisted, क्या हो जाएगा? This will be forming as a loop here. ठीक है? This will be forming as a loop, and once a current carrying loop is formed, there they will be producing magnetic field. ठीक है? This magnetic field produced will be exerting force on the nearby current carrying conductors. Why? Because force is there, I L cross B. है ना? So if you don't want this to happen, you will be what? You'll be twisting together all these wires so that it will not be forming as a loop like this. ठीक है? So reason is, if the wires are not twisted, combination of the wires forms a current loop. Yes. In the magnetic field generated by the loop might affect adjacent circuits or components. Yes. ठीक है. So both are correct and reason is a correct explanation. है ना? Okay. Okay. Everyone, shall we proceed further? Shall we go for our next chapter of this particular session, which is magnetism and matter? Here most of the portions are deleted. We can complete this in half an hour. ठीक है? We can complete this in half an hour and we'll be finishing it by 9:15. At 10 o'clock, we'll be restarting our third session. ठीक है? Chandan will similar kind of questions you can expect. Don't ask me, sir, is the same question gonna come? ठीक है? Okay. Now got it. So हम जा रहे हैं. Initial portions are deleted. मतलब electric field produced by a solenoid or a magnetic dipole, all those portions are deleted. Right? Torque by a bar magnet we already have discussed. potential energy is something which we haven't discussed. Matlab, if we are having a magnetic dipole which is kept in an external magnetic field, a potential energy is associated with it. Formula minus mb cos theta, where m is magnetic dipole moment. Okay. B is the magnetic field, theta is the angle existing between, देख ले, ये m का direction, ये b का direction, theta is the angle between them. ठीक है. This is equation of potential energy. Now, if you want to rotate this, if you want to rotate this magnetic dipole from an angle of theta 1 to theta 2, work has to be done because torque exists. What is the formula for work done? Here work is being done to change the potential energy. So work is equal to Q2 minus U1. What is the formula for U2? Minus MB cos theta 2 minus MB cos theta 1. Okay. So minus of minus will become plus. So MB inside the bracket cos theta 1 minus cos theta 2. This is the formula for work done. You can use it accordingly. I don't want you to by heart this formula. You just need to by heart this minus MB cos theta. Okay? And you just should be knowing. I think everybody knows. 11th standard everybody passed and came here. Work done is U2 minus U1. है ना? और क्या? इसमें इतना बड़ा कुछ भी नहीं है. ठीक है? सिंपल सा छोटू सा बात है. Gauss law in magnetism. याद है Gauss law in electrostatics? What does it say? The integral of electric field over an entire Gaussian surface, मतलब a closed loop, is equal to 1 by epsilon 0 times the charge enclosed. है ना? Now, if you try to apply the same thing over here, okay, if you try to apply the same thing over here, matlab integral B dot ds, ds matlab area, B is magnetic field, what will you get is 0. Matlab if you try to find out integral of B dot ds, B dot ds क्या आता है? अरे E dot ds क्या आता है? It was electric flux. मतलब total number of electric field lines associated with the surface. B dot ds क्या आता है? B dot ds मतलब the total magnetic flux associated, ठीक है, that will be given as 0 here. What does it mean? इसका मतलब क्या है? All the time if you are taking a closed surface, the field lines associated is 0. इसका मतलब ये कि magnets will always be existing as magnetic dipoles. Okay, I know that some of you didn't understand. देख ले, ये हमारा surface है, ठीक है. Let us take a magnet. Magnet will always be existing as a north and a south pole together, whatever we do. The proof is Gauss law. Gauss law says integral B dot ds matlab total flux is 0. Let's see how the total flux is coming at 0 here. From north pole, field lines emerge, है ना? ऐसे जाके it will be coming. One is exiting, so flux is +1, and on the other side it is entering, so flux is -1. What is the total flux? +1 plus -1, 0 हो जाएगा. Understood? So if flux associated with is equal to 0, it simply means inside that magnet, inside the closed surface, what is remaining is magnetic dipole. ठीक है? And one more thing, and Gauss law tells that magnetic monopoles does not exist. Magnetic monopoles doesn't exist. Monopoles matlab a north pole as such. You can't have a magnet with north pole alone. It will always be existing as north and a south. This is what is said in Gauss law. ठीक है? Okay. Moving on. Okay, almost last topic, Earth's magnetism. You know that Earth is producing the magnetic field as if, right? A bar magnet is kept well inside the surface of the Earth. You know? Is a bar magnet existing? No. But the magnetic field lines are acting like there is a bar magnet inside. Let's go for a look. ये actual north of the Okay, this is the actual north of the earth and this is the actual south of the earth. If you connect a line between them, we call it as geographic axis. Now, the magnetic field lines are acting such as there is a bar magnet kept by making a small inclination with the geographic axis, where the north of the magnet is found to be very close to the geographic south, and the south of the magnet, okay, yellow is not something which you can see, na? Where the south of the magnet is found to be very close to the geographic north. Now, if you connect a line between the magnetic south and the magnetic north, you will be getting a line which we call it as magnetic axis. There exists an angle between them, 11.3. Matlab, there exists an angle between the geographic axis and the magnetic axis with a value of 11.3. Fine, it is very important. Now, let's learn what is geographic meridian and magnetic meridian. क्या होता है? देख ले. Geographic meridian. Now, if you want to know what is geographic meridian at a point, देख ले, I am taking this point. Can you all see that? I just took a point. So for finding geographic meridian at that point, you just have to draw a plane. Okay, geographic meridian is a plane passing through this point. ठीक है, ऐसे जा रहा है, plane जा रहा है, and also passing through the geographic axis. Okay, a plane passing through a point. It's a plane passing through a point on Earth and geographic axis. That plane we call it as geographic meridian. So what will be magnetic meridian? Very simple. क्या होता है? A plane. ठीक है? It should be passing through the same point and it should also be passing through the magnetic axis. Then that plane form we call it as magnetic meridian. हो गया? Geographic meridian. ठीक है? Magnetic meridian हो गया? ठीक है? Then there exists an angle between them at different points. Okay, at different points. If it is having some angle here in Kerala, the value of angle between magnetic and geographic meridian will be some other angle in Bombay, some other angle in America, some other angle in Africa. Okay, so that angle between the geographic meridian and the magnetic meridian, we call it as magnetic declination or angle of declination. देख ले, ये तो geographic meridian का plane है, ये तो magnetic meridian का plane है, an angle between them exists, वो होता है magnetic declination. Very important, very important. So as a definition, most of the time you can expect this. ठीक है? ठीक है bro, चलो. What is magnetic declination? Question can come as. Next, angle of dip. वो क्या होता है? Let's say this is हमारा surface. Okay, Earth surface. So at this particular point on the surface, let's say the net value of magnetic field is B and in this direction. Can you see this angle which is formed between the horizontal Earth surface and the net value of magnetic field? वो होता है angle of dip. That is what is called as angle of dip, right? Or angle of inclination. Don't think that angle of dip and angle of declination are same. बिल्कुल नहीं. Angle of declination is one thing. Angle of dip or angle of inclination. समझ में आ गया? ठीक है. From if you know B and if you know phi, we can find out horizontal component of Earth's magnetic field and vertical component. So what will be horizontal component? अरे ये B है, ये phi है. The closed component, this is B cos phi. Isn't it? How will you find out the vertical component? B vertical will be equal to B sin phi. Now tell me what is B vertical by B horizontal is going to be. अरे B cancel हो जाएगा. What is remaining? Sin phi divided by cos phi. ये हो जाएगा tan phi. Simple as that. हो गया काम है ना? So this is only something related to angle of depth. Now, if BH and BV are two components of B, without even telling, you know that B is equal to root of BH square plus BV square. So I don't think I need to explain on that particular concept. Okay. So yes, moving on, but chalo, ये clock क्यों आ गया? Now, last topic from this particular chapter हो गया. इसके बाद मतलब some terms related to magnetism. Shall we do that? वो हो गया तो हो गया. What do you all say? वो हो गया तो हो गया, काम हो गया. Then we'll do some multiple choice question and उसके बाद done done done. Yo, हाँ, ठीक है ना? And then after the session we'll be meeting at 10 o'clock for our final marathon series, which is alternating current and AC. हाँ हाँ बिल्कुल दे रहे. We have done so many questions है ना? Okay, so ठीक है. Let's proceed. Intensity of magnetizing field H क्या होता है? Let's say we have a magnet. Near to that you are keeping an iron nail. What will happen? This iron nail will get magnetized when you keep it close to the magnet. ठीक है? The ability of this magnet to magnetize this iron nail is called as intensity of magnetizing field. What is intensity? It is the ability of a given magnet to magnetize a given material. That is called as intensity of magnetizing field H. It is given by B naught divided by mu. What is B naught? B naught is the magnetic field produced by this particular magnet divided by mu naught. I'll write it here once again. So intensity of magnetizing field is B naught divided by mu naught. Fine. B naught is a magnetic field that itself produces divided by mu naught. हो गया काम? ठीक है? With a smile बोल दे हाँ sir बिल्कुल. और क्या? Now, if you are talking about H value of a solenoid, ठीक है? If we are talking about intensity of magnetizing field of a solenoid, so what will be the formula? B naught by mu naught, है ना? B naught by mu naught. Tell me what is B naught of solenoid? Mu naught Ni, है ना? Divided by mu naught. Mu naught cancel हो जाएगा. क्या मिल जाएगा हमको? Ni मिल जाएगा. So H of a solenoid का H value Ni. Else the general term is, the general value of H is क्या है? B naught by mu naught. ठीक है? समझ में आ गया सबको? Okay. Next, moving on. Now, बच्चा लोग, when iron is kept near to this magnet, it will get magnetized. ठीक है? Now, the ability of this iron or any material to undergo magnetization is called as intensity of magnetization. Next, what is intensity of magnetization? वो क्या होता है? It is the ability. It is the ability of a given material to undergo magnetization is called as intensity of magnetization. ठीक है? Now, intensity of magnetization I is equal to, if M is the total magnetic dipole moment of that material divided by if V is the volume, intensity of magnetization is M divided by V. ठीक है? I is given by the formula of M divided by V. Okay. एक और formula है, intensity of magnetization I is equal to, देख ले, if Bm is the induced magnetic field, मतलब in the iron nail, let's say the induced magnetic field is Bm, Bm divided by mu naught is equal to I. Another formula. ये दोनों formula काम हो जाता है for finding intensity of magnetization. Write it down. जल्दी से. हो गया? We are almost at the end. हो रहा है. Almost at the end. Magnetic susceptibility. क्या है? What is magnetic susceptibility? Magnetic susceptibility is equal to intensity of magnetization divided by इंटेंसिटी ऑफ मैग्नेटाइजिंग फील्ड I/H, रेशियो ससेप्टेबिलिटी बोलता है, ठीक है. देन there is a relationship between susceptibility and relative permeability. क्या है पता है? 1 plus susceptibility is equal to relative permeability. This is also important. We are going to do one question based on this. 1 plus susceptibility is equal to relative permeability. हो गया. Okay, हो गया काम. So from here we're going to do the problems. If you all give me thumbs up, I can show you the. सर सुनो कुछ आवाज आ रही है वीडियो में ब्रेकिंग की, प्लीज ठीक करवा. अरे अभी भी है क्या? आप ही बोल दो. चलो कोई साउंड कुछ आ रहा है? कोई साउंड कुछ आ रहा है? Okay, I think no, right? नोक्षी आपके पास भी है? नोक्षी आपके पास भी है? आपके पास भी? Susceptibility is equal to relative permeability. This is also important. We are going to do one question based on this. 1 plus susceptibility is equal to relative permeability. I'm just trying to listen, okay? Okay. हो गया काम. So from here we're going to do the problems. If you all give me thumbs up, I can show you the. सर सुनो कुछ आवाज आ रही है वीडियो में ब्रेकिंग की, प्लीज ठीक करवा. अरे अभी भी है क्या? आप ही बोलते हो. चलो. Okay, so it's not a big deal I suppose. So I just listened to almost 1 minute. So very rarely है ना, छोटू सा आ रहा है. But anyway I'll be looking into it. ठीक है. So ये क्वेश्चन करवा दो. ये क्वेश्चन कर लो सबने. Everybody. निवेश, it's okay, we can manage. वाह वाह वाह, अच्छा बच्चा. ठीक है खुशी, थैंक यू. ओके, ठीक है, जल्दी से. एंड वेटिंग फॉर द आंसर्स यार बच्चा लोग. Everyone like the session, Anushka. अरे just like Anushka is telling, if you all have understood everything, so don't forget to leave that small like button. ठीक है. So that will be a small thing you all can do for continuously me standing here for how many hours? Many hours, I think 3-4 hours, and still 1.5 hours more we have to go. Good to have you back here, Bobby. Okay, so I'll do it. So खुशी says option A बोल रहा है, राहुल A option दे रहा है मुझे. ठीक है. मेरा is like always, just like always, A और B. जीत सिंह जकर, अरे बाप रे. क्या क्या क्वेश्चन पूछ रहे हैं आप लोग. ओके, बाइसेप्स दिखाने का, अरे बाप रे. आई हैव नो रिप्लाई फॉर दैट. मुझे कुछ भी नहीं है उस पर. राइट. ओके, सना, आस्था, सबरा, वेरी गुड वेरी गुड. सो लेट अस डू दिस. ठीक है. एवरीवन इज गोइंग फॉर द ऑप्शन ए. बिल्कुल ऑप्शन ए ही करेक्ट है. वेरी गुड. देख ले. मैग्नेटिक फील्ड and magnetic intensity are respectively 1.8 Tesla. So the total magnetic field B, total matlab B naught, matlab the magnetic field produced by the magnet plus BM. BM is a magnetic field induced inside the material. Formula is mu naught H into 1 plus susceptibility. ठीक है. Fine. Now what is 1 plus susceptibility बच्चा लोग? Relative permeability. सबको पता है. So 1 plus susceptibility mu relative is equal to B divided by mu naught H. Okay, just substitute for B mu naught and H, काम तो हो जाएगा. Okay, अरे बाप रे, B का वैल्यू कितना था? magnetic field was 1.8, okay, and the other one was 1000, ठीक है. So 1.8, h का value 1000 and mu naught का value 4 pi into 10 power minus 7, that is equal to mu r. कितना मिल जाएगा आपको? ये 1432 मिल जाएगा. 1432. Relative permeability का value मिल गया. Now you know that relative permeability is 1 plus susceptibility है या नहीं? हाँ. So substitute कर ले. 1432 is equal to 1 plus susceptibility. So susceptibility का value 1431, which simply says हमारा option क्या होता है? हमारा correct option यही है. So we just have proved it. Not a big deal है ना? उतना तो बड़ा question नहीं है, as you all can see, isn't it? उतना तो बड़ा question नहीं है, as we all know. So we're gonna proceed further मेरे बच्चा लोग, ठीक है? Next, how many questions आते हैं? अरे हो गया. Okay, do this. अच्छा वाला question है. अच्छा वाला question है. So you don't show that you are tired. Thank you so much. Arey baap re. Thank you, Raki. After this class, I'll be running. I think my mom has made something special. So let me go and eat. I'll be back at 10 PM. ठीक है? ध्रुव कब खत्म होगा? 5 minutes. हो गया हमारा. This session will be ending in 5 minutes and we'll be resuming at 10 PM for the final revision, which is EMI and AC. Isn't it? Yes, Deep, बिल्कुल बिल्कुल. That's the reason I am continuously इधर तो session ले रहा हूँ, so that everybody can understand this, है ना? देख ले. If Earth's magnetic field at some place on magnetic equator is 0.5 into 10 power minus 4. Magnetic field का value दे दिया है 0.5 into 10 power minus 4. ठीक है. Question is, अरे Earth का radius भी दे दिया, which is not at all necessary. Then what is the horizontal component of magnetic field at the equator? Question is BH. Formula क्या है? B cos theta. B is how much? 0.5 into 10 power minus 4. Now theta का value substitute करना है. ठीक है? Theta means angle of tip. ये हमारा Earth है. Inside the Earth, here we have our magnetic dipole. It acts like magnetic dipole is kept inside the Earth. ठीक है? So either we have the north and here we have the south. From here magnetic field lines ऐसे it will be going. Now angle of dip means the angle that is formed by net magnetic field. देख ले. Net magnetic field with the surface. Surface is also in this direction, है ना? Tell me what is the angle? You only tell me. बच्चा लोग आप ही बता दें एंगल क्या होता है. थीटा कितना? हाउ मच इज थीटा? आई थिंक राखी. अरे वेरी गुड राखी. इट्स जीरो. वेरी गुड. अमेजिंग. दोस हु डिडंट अंडरस्टैंड, आई थिंक नाउ इट्स क्लियर, है ना? इट्स जीरो. सो थीटा के लिए इधर जीरो सब्स्टिट्यूट कर ले. सो दिस इज cos 0, which will give you the answer as क्या? Which will give you the final answer as 0.5 into 10 power minus 4 और क्या, है ना? देख ले. फाइनल आंसर मिल गया. ओके. सर सीबीएसई का पेपर आप ही बना दो सर प्लीज. अरे बाप रे. आई ऑल्सो लाइक टू. मुझे कोई ऑफर नहीं कर रहा है मुझे. ओके, मूविंग ऑन. लेट्स सॉल्व दिस बच्चा लोग. लेट्स सॉल्व दिस. अरे ये क्यों आ रहा है? बाय जा. Assertion recent type. Assertion recent type. Anushka, there is no class. Today we are completing everything. Sab pura ka pura. है ना? In one day we are completing the entire thing. So kal it's time for you all to revise the session, to do some extra MCQs by yourself. Okay. हो गया? Waiting for answers from all of you. A, B, C, D. Which one? C, D, C, D, C, D, 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 D. अरे ऐसे कैसे? So हमारा करेक्ट ऑप्शन बच्चा लोग ए ही है. क्यों? What happened? Let's read. To protect any instrument from external magnetic field, it is put inside an iron box. क्या हो जाएगा? ये हमारा iron box है. ठीक है? Let's say it is having some width. Now, if some external magnetic field is coming ऐसे, if some external field is coming ऐसे, देख ले, this is an iron box, है ना? It's an iron material which is a conducting. So, it has more permeability. So, all the magnetic field lines will be passing through this particular iron box ऐसे. All the magnetic field lines will be passing through this iron box because it has more permeability. Permeability means it allows more amount of magnetic field lines to pass through other than the air inside this particular box. So you can see that the space inside this box is well protected from external magnetic field. So if you want to keep any material safe from external magnetic field, क्या कर सकता है? You can keep this inside the box. ठीक है? So yes, that is correct. समझ में आ गया सबको? आ गया सबको? आ गया, आ गया, आ गया. Yes, to protect any instrument from external, it is put inside an iron box. True, iron is a magnetic substance. True, and that itself is a reason for the inside region is protected from external magnetic field. हमारा correct answer option है. हो गया? हो गया बच्चा लोग, हो गया बच्चा लोग. So successfully मेरा बच्चा लोग, we have completed 2 sessions of हमारा marathon, and within 45 minutes we'll be starting our final session, EMI and AC. Okay, at what time? At what time मेरा बच्चा लोग? बोल दे at what time? बोल दे at what time? At 10 PM we have our next session. How many of you are gonna come? कौन कौन आ जाएगा बच्चा लोग for our final वाला, for our final revision of the last chapter? Right? 10 PM, everyone. Right? I want every one of you, or just spend 1.5 more with me so that the entire revision is over, है ना? So within this one day, हो गया? ठीक है. So Nokshi, Abhilasha, Niveng, Sabra, Tushar, Vansh, Meenakshi, everyone. Yogita, Myara, Jodi, Anushka. Yes, let's crack it. Kushi, Bobby, Stanzin, Srikant, Myara, Mega, Varshini. Arey baapre. Very good, Ratreshwar. Very good, baapre. Everyone is super interested here. So I'm so lucky to have such an amazing crowd here in the classroom. So see you all at 10 PM, bachalo. I'll be updating the notes of this session, okay, in the Unacademy class 11th and 12th Telegram. This is already updated. This I'll be updating, and I'll be updating the notes of EMI and AC also. Chalo, what you all can do is just keep supporting me, है ना? कैसे support करेगा? Move your cursor. कर सकता है? Just move your cursor. Okay, and click on that like button. कर ले वो, कर दिया तो थोड़ा प्यार हो जाएगा, है ना? ठीक है. So I think who haven't liked the session, जल्दी से like कर ले. These are the other batches for 11th and 12th. What is going on? So plus subscribers offer is going on for the first 1,000 subscribers. Extra 6 months is given as free. Okay, special class timetable, special class features, and now this page is also asking you the same thing, to like and share the class. Bachalo, kindly share the class to all your friends because let them also get benefited, है ना? Let them also prepare in the best way possible for the upcoming term. So क्यों नहीं? Subscribe ही कर ले. Okay. So thank you so much everyone. Thank you so much. We all will be meeting at 10 p.m. Okay. So everyone right now have food. Be healthy. I'm also running. जल्दी जा रहा हूँ. मेरा मम्मा बुला रहा है मुझे. Okay. So I'm also going to have something. Let's see what is going to be there. So thank you so much everyone. Bye bye. Take care. See you all within 45 minutes. Bye bye.